Good morning, everyone. A very warm welcome to all the participants to the seventh session of our AICT Atal Faculty Development Program on Industry 4.0. We have completed six thought-provoking and insightful sessions so far, each providing a deep understanding of the technologies and innovations shaping the future of Industry 4.0. Now we are moving towards another exciting session that focuses on one of the most dynamic pillars of this revolution, Industry 4.0, towards sensors, IoT, and automation. It gives me immense pleasure to introduce our esteemed resource person for this session, Dr. Vijay Kumar Pal, Assistant Professor in the Department of Mechanical Engineering, IIT Jammu, Jammu and Kashmir. Dr. Vijay Kumar Pal is also serving as a visiting faculty at Kansas State University, USA from December 2023 to June 2024. He holds a PhD in mechanical engineering from IIT Kanpur and MTech from IITDM Jabalpur and BTech from AKTU Lucknow. Dr. Pal has an extensive teaching and research career, having served at reputed institutions such as NIT Silchar and SRM Institute of Science and Technology, Chennai, before joining IIT Jammu in 2018. He has published more than 20 international research papers in reputed journals and has been actively involved in several hundred projects supported by agencies like DST, MSME, and IIT Jammu, covering areas such as nanomanufacturing, hydrogen storage system, and stretchable electronic circuits. With his rich experience in advanced manufacturing and automation technologies, Dr. Vijay Kumar Pal's insights will certainly help us understand how sensors, IoT, and automation are reshaping industrial processes and paving the way to a smarter and more efficient manufacturing system. On behalf of the Mahavir Polytechnic, Nashik, I extend a very warm welcome to you, sir, and thank you for joining us today to share your valuable knowledge and expertise. Sir, we now invite to take over this session. The virtual stage is all yours now.
Yeah. So thank you, Sambhaji sir and Mr. Sonavane ji for organizing this wonderful program under the umbrella of Atal. And as the theme of this, FDP is very clear that it is Industry 4.0. And I would like two-way communications, because what I thought, it's a very catchy word nowadays, and most of us, irrespective of our branch, irrespective of our area of research, try to merge the research in this particular area. But before understanding what exactly is Industry 4.0, what exactly is the need, we cannot do anything, right? Because in general, I believe that most of you are from the mechanical engineering background, right? And maybe some other department also joining here. But this word covers all the departments, including computer science, mechanical, electrical, and so on. So what I thought, I will give you a very basic example in the beginning, okay, which is most of you are using in daily of your life, because we are all academicians and we know how academic institutes work, irrespective of whether it is IT, NIT, Center Government Institutes, State Government, Polytechnic, or whatever. So, so I believe that most of you are actively listening my talk. So I just wanted to start this session from your office work. For example, just I wanted to know, let's
Absolutely.
say Umair Sakji is here. Umair ji, are you there? Umair ji? Okay. Manish Mardi? Manish,
Yes, sir.
Manish ji, where are
Yes,
you
sir.
working?
No, no, sir. I'm just academician, PG academician,
Okay.
research scholar.
Anybody faculty here? Anybody? Rani Vinayak, I can see. Srinivasu ji, no? Anyway, somebody said, so initially, I would like to show you what ERP model we are working as well as we are developing at IT Jammu for daily day work. For example, in any of the academic institute, because first we need to understand what exactly is the automation, whether it is always hardware type or whether it is always software type or it's a mixture of software and hardware, right? Because nothing is new. In the end of this talk, we will see that already we are working in this type of areas, but because of some new terminologies, most of people are confused whether we are working in this area or not. Because the broader classification of mechanical engineering is design, thermal, manufacturing and robotics, right? But because of some new terms, industry 4.0, smart manufacturing, blockchain, cyber security, the fear has been generated that I cannot work in these areas, right? So let us now understand what exactly is this. How can we connect our work from these recent terminologies, AI, ML, deep learning, machine learning. So most of the titles I try to cover in my presentation, so that we all can understand what exactly is this and how can we correlate our work in this. Anyway, I will give you the basic example from our daily life. Let's say in any of the academic institute or any of the R&D institutions, there are some set of protocols. For example, somebody sir is working in some institute and they got this approval to organize this workshop. Of course, there is some funding agency where they approach with some proposal, and based upon their proposal they accepted it, and now they are organizing this thing, right? For organizing this thing, they have to take some administrative approval from their institute. Some financial team will be there who will take care of all those things. Apart from this work, he must be engaged in teaching, where he will taught some of the courses, some of the laboratories. Similarly, he must be involved in some of the research areas where he is dealing with some of the research projects and all those things. So why I'm highlighting this thing, because from this example we can easily understand what exactly is the automation, let's say. So I will give you some example first. Let me share my screen. It is not allowing to share my screen.
Let us suppose.
It is allowing me to share the PPT.
Yes, sir, you can share now.
Okay, so my it is basically showing, allow me to show my this thing. Acha, can you see my screen here? What is visible now? Can
Yes,
you
sir.
see?
Yes, sir. Yes, sir.
So,
Visible, sir.
can you see my ERP screen? Vijay Kumar Pal, mechanical engineering. This is written. No,
Yes,
Yes,
sir.
yes, sir.
right? Sir, what are you saying now? What you can see?
Sir, please make it full screen.
Just a minute.
There is a microphone on off, sir.
Can you see now? I
Yes,
mean,
sir.
my
Yes,
ERP
yes, sir.
screen.
Yes, sir. Visible, sir.
Yeah. So it is very simple. Now let's understand why I am showing this to you. This is the ERP system which we developed in-house at IT Jammu to run the daily activities. Let's say in daily activities, any academician have to deal with the four major pillars. academics, research, admin part, and some sort of store and purchase things. Okay, so
Technical.
what I'm showing this, let's say for any type of approval, let's say higher level approval, the typical procedure is one can initiate the note manually. It may go to the HOD or principal or some dean level, right? And then we are waiting for the top level authority, whether he is the director, dean, or whatever. So sometimes it is taking time, and sometimes you have to organize everything in a very urgent situation. So what we decided, let's say for day, anything for the approval part, there is a note, you can see office note, green color. I hope that is visible. Can I do this? Sir, can you see what I'm doing now? No? Or
Yes,
it is
sir.
showing? I'm entering OTP, it is showing now?
Yes, sir.
Okay, good, 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 good. So just make a patience. It is very interesting thing. Let's say I have my ERP system in hand. Okay. So here you can see the broader classifications. First, I will show you the node thing. This is an ERP node. Can you see?
Yes,
Okay.
sir. Yes, sir.
Yeah. So any type of extraordinary approval, some special approval, something happened, and something if I wanted to do immediately. Okay, let's say for this thing, request for approval of additional travel fund or whatever extraordinary thing. So we have a very dynamic module. Let's say for example the smart India hackathon, anything. So what we can do,
Huh?
this noting can be do immediately. Let's say I wanted to do something where I need administrative as well as financial approval from the director. I can write directly to my head of the institute with some details. It directly go to the, let's say, director level, and I can contact my director through phone call or let's say WhatsApp, that this we have decided and now I need a administrative approval quickly. Whether he is in India or abroad, he can immediately recall our discussion and do something. Okay, let's go ahead. So once you have a go ahead thing, you can move on to the top to bottom approach, and you can do the other things. So why I'm showing this, this is a basically typical noting we have initiated at IP Jammu. Is it visible, sir, to you?
Yes, sir.
Sir? Yeah. So let's say this is the note. Now I'm coming to your activities. Let's say I am regularly dealing with these things. Okay. Let's say we all are dealing with the academics. I wanted to recall that what course I taught 8 years back, or 10 years back, or 5 years back, and what was the number of students, what was the grading out of that. Because in future, let's say you wanted to see the grading of your student, where he wanted to seeking your recommendations. So what you can do, there is a typical academic portal, you can see here. Here a lot of things are there, my academic calendar, what are the courses I am offering, right? So let's say in general I will show you the basic thing, my courses. Let's say here whatever courses I have taught so far, you can see, and I can see all the things. Okay, let's say some courses was there. I can see my feedback, I can see my flow, I can see my number of students anywhere. Okay, so quickly I can see how many students are registered, what are their mobile numbers and all. Let's say, and after that I can submit their grades, and I can see their previous grades and all those things, whatever anybody has taught so far in last, let's say 7 8 years, whatever. So what I'm showing this thing, it is this is also example of some sort of automating the things. Everybody is doing manually. Sometimes you need to rely the hard copies of that. Sometimes you need some urgent information when you are in home. Sometimes urgent information is needed when, let's say, some off timing and all those things. So this is the system which not required much recent technologies, but some sort of coding skills, some sort of approach, that what you are wanting to achieve, and you can easily make it. Okay, I can see everything here, TA and all those things. I can float my courses, Let's say I can float my courses, my grade entry, my timetable, my course template, my grading, and so things. So what I am showing in general, I am not going to detail in this, that this is the typical academic portal, which is almost automated in nature.
Kiran Jadhav, join
For
the live.
example, I guided my student, PhD student. I wanted to see when he defended, or when he has finished his comprehensive, or when he finished his state of the art, and when what is his track record. So it is very easy. These are the PhD process. You can see here student SRC is there, progress report, comprehensive exam, doctoral thesis, seminar, synopsis, and everything. You can see it very easily, right? So this is the typical automation system. You can see it from the academic portal. For example, other example is for scholarship process. A student will apply the scholarship. It will come to my window. I will immediately do their processing. No need to come student. He is waiting for me, and then I will sign it. Then it will go to the academic office and all. So there is a very clear process. Let's say whenever he will apply for uh, he will apply for this any scholarship things. Okay, it will come to me, then it will go to, nothing is pending in my window, that will it goes to the staff. And I can track also, I can track each and everything. Let's
Ali
say
join again.
progress report, okay, whatever reimbursement my student has taken from me. Okay, so all are the details here. How many students I
Ali
have
join na
guided
na
from
Ali.
here, any summer student has joined under me, so each and
Baba
everything is
yela sa
completely
lal sa
automated.
chumak.
No need to wait for the academic office, no need to come to my office. And also, I hope that you must have understand what I am trying to convey from this slide. Anybody can respond? Yeah, should I move forward? I am audible? हाँ आप ले लेना.
Yes, sir, you
Uh,
are audible.
yeah. So I mean, try to make it interactive if you are interested. I mean, others also. So what I'm showing this thing, because once we understand this, then we will quickly move to the other technical part, that what manufacturing industries are doing. So assume that this system is a sort of automated system, and then we will try to connect from each and every one, irrespective of you are design fellow, robotics fellow, manufacturing, or whatever, right? So here you can quickly see that what type of automation we have done for the academic point of view, let's say. Now, the second responsibility, which is most of us we are doing, is the, let's say, research work. Okay, so here you can see in the right side, this is my academic portal. Let's say my RNC portal. I received one project, then no need to go wait for the academic office or RNC office that I received the sanction letter, then I will go there and tell them that you initiate the process and all those things. It is very interesting, portal. For example, I can see my projects from this window. Okay, so yeah. So whatever projects I am dealing or I have finished, it is here. So why I'm showing this thing? Let's say this is a basically, sort of thing which I can show you, that let's say we received the sanction letter from some funding agency, then you wanted to initiate and all those things. So everything you can see here, that my endorsement letter, sanction letter, and all those things. What I need to do, only I need to fill this detail and write the comment that I have received this much of amount from here. It will go to the R&D office, and it will go to the dean office, and it will approve. Once it will approve, this is the sanction amount. Let's say the 30 lakh is the sanction amount. But the major task is, I mean, sometimes the project are scaling type of project, sometimes the project are R&D projects, sometimes different, sometimes consultancy. So the major problem was, how can we track our fund, right? So very interesting thing is that we have developed a report section here. For example, any type of report, I can see it here. Any type of report means academic, research, admin, whatever. Let's say I'm interested to see my research work. I can go to the my research work. Okay, for example, sir is there. he is organizing this faculty development program, and he has received some fund, and out of that he's started, the expenditure of that. But he sometimes he need the help of the staff, that how much fund is spending, how much fund we can use further, how can fund I can modify, and all those things. So here I can see my statement of expenditure depending upon my project. For example, let's say I have one project, let's say some research project, I will show you, because then you can easily understand. Okay, so here in general, let's say the budget was divided in contingency, equipment, miscellaneous, travel, and sometimes manpower, let's say. And year by year I can see my expenditures. You can see here the actual expenditures from 22 to 23, let's say, then 23 to 24, then 24 to 25, and let's say then 25 to the completion. I can see what is the committed budget and all those things. Let's say this is the committed budget. Committed budget means the PO has been sent to the vendor and this amount has been committed. Okay, and what is the pending budget with us? For example, in the contingency head, do we have some budget? Here you can see some amount is
बजेट
there.
काय रे
So
कसं
whenever I wanted to initiate new
असं
thing,
बजेट
I can
वाढतंय
track it very easily from my office, that how much fund is there and in which particular head. For example, I wanted to travel somewhere, so I need to see whether the travel fund is with available or not. So let's say the 2 lakh was the travel fund, and let's say I can see, yeah, so it is very 12,000 something. So I need to decide whether I can use this project for my travel, or I need to take approval from the another project. Otherwise, sometimes it taking too much time to track it from the offices, right? So this is the typical example of the generating of the project. Now, very interesting case recently what I do. So let's say I showed you the academic portal. Now I am showing you the RNC portal. In RNC portal, I have shown you two things. First one, I received the project, I create the project, and now I can see my expenditures. Now, I wanted to make a special request to my dean or director for the adjustment fund, internal adjustment from this particular project. Let's say I wrote one project internally or externally, but I proposed some equipment, and later on when I received the sanction letter, I observed that this type of equipment was procured by some other faculty. So I wanted to revise, my equipment. Suppose A equipment was needed initially, but when I going to procure it, it was already available. Then I thought, okay, I don't need A, I need, let's say, B. So where to reach and how to reach? Again, the procedure was you need to meet to the dean director, discuss, and then file moving and on. Here we have created a very interesting feature. Let's say RNC request. Any type of RNC request from the projects, I can track it. For example, recently I made it. You can see here request for revision of the equipments and its approval. So very simple way. I need to just write this thing with my justification. It will typically go to the R&D office and they will give me the date. That this is the date. You need to come and just discuss with the dean. And once dean will approve, you can go ahead. Similarly, for anything, I wanted to release the honorarium, I wanted to release the consumables things, I can initiate the RNC request from this particular window. I hope you can understand what type of automation we are doing. And you believe these similar things we are doing in this industry 4.0 and smart manufacturing and all those things. Because ultimately the aim is to improve the productivity, accuracy, and all those things in engineering systems, right? So this non-tech thing you can easily relate with the technical thing very easily. I hope that this is clear to you, that I'm not going to touch the other part, but very basic part which all of us are using. This you can understand from here. Now, third thing, purchase, the complex process, right?
हे
Because
माल enjoy
every
कर
time government is changing
माल enjoy करना
rules for gem, non-gem things and all those things, then who will read these
तरी
rules?
ऍडमिट हो राहिला वो
Right? Because sometimes what is happening, you wanted to do something, you wanted to procure something, you initiate a request either manually or whatever procedure is there in your institute, then some procurement office will say, no sir, this is not allowed as per this rule and that rule. How to automate it? how to make it automate, that why we are waiting for the new rules. So whenever new rules is coming, you must add this thing in this EG so that I can do it from my office. Can I show you one basic example here, because most of us are dealing every day with this?
यस करना.
Okay, I covered academics, I covered RNC means projects. Now I am touching the purchase. Let's say I go right side and see my purchase. Okay, for the purchase thing, the typical procedure is again the approval thing, committees, and all those things. How to automate it? Because the purchase is, have lot of variety. Sometimes it is consumable, sometimes it is non-consumable, sometimes it is available in gems, sometimes it is non-available in gems, sometimes it is a scientific equipment which is coming from out of India, you need to some prior approvals. Sometimes the amount also, plays role to make the committee and frame the committee and all those things, right? So why I am worried about it? Can we automate it? So this is the first institute in India, I can say, where this is the complete automated system. Let's say I wanted to purchase something. Okay, so when you are going for the purchase, of course the basic point is what is the amount and what is the nature of your purchase, right? For example, add new, whatever things are there you can see, because whatever you are doing manually, I am doing it automatically. This is the overall theme of this workshop, right? Industry 4.0, automations and all. Okay, so we have made some category that whether your purchase is less than 15 lakh or more than 15 lakh. If it is more than 15 lakh, then it goes to the higher committee, and if it is goes to the 15 lakhs, then it is goes to the some particular dean level or whatever. All right, so these all are approval already have been taken, and now we are including in the ERP part. For example, I wanted to procure my scientific equipment, so I need to see whether GTE approval is needed or not. That's for furniture and everything. So we have classified that what type of procurement in general we are doing, right? So in general, 70 or 80% procurement was our research part, right? And some institute services and all. This is not my task, this is maybe taken care by some other task. So let's say I will show you what we are dealing every day. Let's say I wanted to purchase something. Okay, so I can give whatever details, whether it is a consumable or whether it is a non-consumable or whatever. Anyway, so let's say I give example of consumable of some small amount, whatever. Okay, some name, some. So what it can do, it can ask you, I mean, whether you have project from where you wanted to approach. For example, if I wanted to procure something from my project, right, then there is a separate route. For example, something I wanted to purchase from the institute fund, then there will be a separate route, right? Whether, so let's say I can give you some example. Let's say either through, let's say, project, or let's say from seed grant, let's say. Okay, so automatically it will understand that it's some sort of grant. Then department must be RNC. Then I need to select. I mean, from where it is external project or external project, then whatever sub cost center and so many things we have added here. Quickly, I need to enter it, and what is the project number. So let's say this is the projects which I am dealing. So I will see which project is suitable for this purchase, or let's say I can start. Okay, so why I'm showing is whatever justify purchase and so many things I can add. The interesting thing is whatever comments I wanted to write, the interesting thing is the amount.
Screenshot
Okay,
master bro.
let's say I wanted to something, and then here details, indent details. Okay, so the component is of course, let's say, some sort of um, consumables. Okay, name of the items, ABC, whatever, description, maybe whatever I wanted to see. Okay, let's say the quantity is one particular thing, or let's say 10, and I wanted some small things in number, and this thing, I whatever is, these are all tentative things. Rate, right? So let's say I wanted very small things which is 5,000 in nature, and let's say I wanted it, I mean, 18 or 19 numbers. So here you can see I fixed the quantity 10, and let's say and the rate is approximately 9,000 per piece. The interesting thing is that I do not need to worry that how the committee will be framed. For example, these are all formalities. That's why I'm not showing to you. Whatever they will ask you the location. If it is coming to my office, I will set my office number. If it is coming to my research lab, then I need to enter my things. Everything is automated. Interesting thing is when I enter, and you can see here that it cost around 90,000. Okay, so as a single individual, I can submit it and I can procure it. Once I will submit, it will go to the next level. The interesting thing is that here you have seen that they never ask you about the committee, that who is your committee members, because from the back end we instruct our ERP that up to 1 lakh for any project, let's say I can decide easily, and I no need to make any committee member on that. But at the same time, you can see when I just change the number, let's say I wanted not 10, I wanted, let's say, let's say 25. Okay, so 25 pieces I needed, and again 9,000, same type of procurement. So when I will do upgrade, it is automatically asking me the committee members. That means if any new faculty has joined, he no need to worry that what is the rule of the procurement, right? Simply he can see in his or her window that he now need to add the committee members. Depending upon the nature of the purchase, it automatically sense. Depending upon the amount, it automatically sense. What he need to do, he need to only just add the committee members. And here you can see my ERP is also instructing me that for, let's say, the purchase which is now I am creating
भाव admit
it
करना.
around more than 2 lakhs. So buyer, that means myself plus 2 members are needed, right? So no need to add any of the chairman. I can simply see who is the relevant members. I can just select buyer as my name. Everything is scripted, so no need to go here and there. Just I need to add my name. Whatever names are there, it will come, and I can simply see whatever reason I am choosing myself. And similarly, for the another committee member, I need to select expert one. Let's say I wanted to see some colleague who is, let's say, working in similar area or whatever. I can choose from here, okay, and I can comment. So what I am showing this thing, you must have seen, depending upon the purchase, depending upon the amount, it automatically instructing me that don't don't go individually for this particular purchase. You need to add 2 more members, right? So it saves lot of my time, lot of my energy, lot of, the discussions here and there. Simply in a 5 minutes I can do my task, and I can insert and I can submit. Then once I submit it, it will automatically either go to my HOD or maybe whichever relevant office. He can only see that whether yes, this is the part of project or is a part of institute, whether fund is available and not. Some type of cross checking they can do, and simply depending upon the cross checking, they can recommend it, and then it will go to the sub dean level or again director level, whatever the nature of purchase is there. So they will approve it. So once you have the indent approval in your hand, that means now you can for the purchase. Then some purchase rules are already there. After the confirmation that yes, I can go ahead for this purchase, I can again send the purchase request. If you remember, I shown you the RNC request where I was asking for the change of the equipment. So here you can similarly do the purchase request. Purchase request meaning, I will show you, that is very interesting part. Let's say, my purchase, whatever I am showing you, has been, let's say, approved. Let's say some small item I wanted to procure 1,60,000, and the this has been approved by dean level. Now I wanted to proceed further. As per the government rules, I need to check the gem availability report. I need to see whether this is available on gem or not. If it is available on gem, then some other procedure is there. I need to sign it, send it, upload it here. It will again go to the R&D office. It will now start the procurement. Similarly, if it is not available on the gem, then you need to come back. You need to float the tender, or you need to receive the quotations, whatever procedure is there. So here you can see very smartly, once your intent hammer is approved, that means green color sign, I can see other options like purchase request.
Thank you very much.
Simply, I can tag the indent
And
number,
also,
whatever indent
the
number,
discussion on
let's say,
4.0 towards
okay. So in any of the
differential
purchase request, what you wanted to do from this
logical
request, let's say
instrument
you wanted gem
and
availability
packaging
report,
design,
or you wanted to
conveyance and
release the PO,
enhancement,
depending upon
planning
the stage of the
of
purchase we
house
are having.
sensors and
Let's say
evaluation of
G
customers
availability
formally
report.
model
Simply, I need to tell the indent
of
number.
sensors and
Whatever indent
equipment
number is
are
there,
performing
I can simply tag it or write it, and then
on
it
behalf
will
of the
go
Mahavir Polytechnic
here,
on
and
participants
I can
and
submit
our
it. Then it will
heartfelt
go to the
gratitude
procurement office.
to
So what it will do,
Atal
depending upon my
for sharing
requirement,
the
depending upon my
valuable time
technical
and
specs,
expertise
they
with
can
us in this
send me the
process with us. I will
report,
also
and this report
thank
again
all the
it's coming
participants.
back online in mode.
I will
For example,
also thank all the
whatever jam
participants
reports
for
I wanted to
active
procure, the
engagement.
refrigerator, whatever things, you can see
Once again,
these
thank
all
you
are the
for
reports they
this
have
valuable
sent back to
contribution.
me,
This
that sir, this is the report which was generated through gem portal, now instruct further. Right, so this is a very good example of the um, automation or ERP things in the case of purchase. I hope that you must have understand that what I am trying to convey you. Again, the message is very clear. We are moving towards industry 4.0. We are moving towards automation. So automation we are doing in day-to-day life also. Just only we need to understand. We need to um, relate it. We need to code it. Sometimes we need to use some sensors. Sometimes we need to add some sort of programming on this particular area. Okay. So again, just to recall you, I have covered academics, I have covered the research, and I have covered your
exactly.
purchase, which is the very much complex things in the scenario, right? And in the beginning, I show you the note also. Now, yeah, so any questions so far? Anybody?
Ganesh, sir, question is
Any participants? I'm audible. Somebody sir, I'm audible.
yes, sir, you are audible.
Yeah. So why I'm showing this thing, because we need to understand that, I mean, automation is not always required in the area of machineries, in the areas of robots or sensors and all. It is everywhere. Only we need to understand the requirement and we need to automate it. Now in the next part, in next remaining time, I have made a presentation for you to more understand on the industry 4.0 point. I will share the slide again.
हाँ जनरल एडमिट कर भाऊ
I hope the slides are visible to each of you. Sir, slides are visible?
यस सर मेक इट पुश सर
Okay.
ए स्क्रीनशॉट मार ना गणेश सर आत्ताचा हा महावीरचं नाव आहे त्याच्यावर महावीरचं नाव आहे म्हणून म्हटलं मार पटकन
Now you can see. is hanging.
अब फुल स्क्रीन नाही हो राहील त्याच्यात.
Somebody sir, can you see now full screen?
Yes, sir.
Okay. Now coming towards the this particular topic, because initially I shown you the daily ways for the clarity of these terminologies. Now, as the title of this talk is towards sensors, IoT, and automation, I hope that the third, which is the last portion, which is automation, I try to explain you with the help of our ERP system. This is basically a typical example of any of the automation. Now, in this talk, I will show you. I mean, others have also must have covered. I mean, that how Industry 4.0 has been evolved and what exactly is the Industry 1.0, 2.0, 3.0, and all. Similar way, I have collected one small video for that for the better understanding, rather saying the theory part. So, in most of the things, what I did, I tried to include the important terminologies, their explanations for the discussion, and some small videos for the better understanding. I have collected this data from many sources, including some popular books in this particular areas and some very useful videos from the industries. So, overall content would be the same, the revolution part, and the important point is the third one, that what is the core pillar of this industry 4.0. And in the last of this talk, you most of you will be realize that we are already doing the same things, but we are not aware about the recent terminologies. And the major drawback was that we are not collaborating each other. That's why we are lagging behind from most of the foreign countries, most of the good institutions. So in general, I will start from the same manner. Exactly what is exactly the industry 4.0. Their four pillars are very very important that I will show you. Now, the how that technologies have been integrated in the factory level. I have shown you one example of our ERP where these technologies have been added in the institutional level to make the smooth functioning, right? Similarly, just assume a case of any manufacturing unit or any other forms where they can use the sensors, IoT, and other things to make the factory smarter, right? Now, then real world examples which are already happening here and there that I will also cover in the fifth part. And the sixth part is where the most of funding is there nowadays, that what are the applications one can choose for industry 4.0. And then of course in the last I will tell you
एक
some benefits.
screenshot
Of course there are some challenges and the current scenario in India. Now, this is the very basic slide. If you remember, it was started from the industry 1.0, where the typical thought was to use the steam power, right? Lot of weaving
अरे
loom
screenshot.
machines was developed. Some mechanization was happening. Like long back, you can see here
आपण
the
नंतर
year
पण
I am
मारू
taking
शकतो.
this course, and 1984 it
माईक
was
कोणाचा ओके.
started,
माईक कोणाचा ऑन
right?
आहे.
Some revolution was happening. And if you remember, that's 30 40 years back, many of the industries were there, now all were stopped because of the recent technologies, right?
माईक पे
Now in
कोणाचा ऑन आहे.
industry 2.0 what happening, people thought, oh, things can be made some sort of
कोणीतरी माईक चालू कर तर.
using machines. Then they added the
नाही
mass
कळत
production
नाही.
part, because initially everything was manually and some
अरे
arrangements
त्याच्यात
they are
तसंच
making
व्हायला
here
लागलं
and there.
नुसतं.
Then in second revolution they thought that we need to increase the production. Then they incorporated the mass production, assembly lines, electrical energy things, and all those things.
अरे ती
But
एकदम
first part
लागत
was
मला
struggle.
आता.
Where is the electrical energy? When they found out, then they tried to incorporate the electrical energy in the industry 2.0. That was also the very huge revolution. So you can see 1784 was started. Then after almost 100 years, the industry 2.0 was the revolution. Then industry 3.0, which we are teaching in most of the institutes to our students, right? We are teaching them CNC, we are teaching them 5 or 6 CNC, we are teaching them codings, we are teaching them some use of software, some interfaces to make the products and all those things. So this was the revolution happened in, let's say, 1969 or somewhere, which we are using now, I can say. This is the industry 3.0, where some sort of semi automation system was created, and we started using of the computers, we started using of the electronic systems, right? So if you see the chain, it was very clear. They, in 1.0, some sort of thought process was evolved. Can we use some source of energy to do something? When they observe, then they move for 2.0. Yes, it is success. Now you need to improve the production part, and then they try to add the semi automation part, where you can see some sort of your CNC machine is the typical example of semi automation, right? No need to operate some machines manually. You are doing it by writing the codes. And now people have added the robot part also, but that is also semi automated, not completely automated. 4.0 is trying to taking care of complete automation. For example, if you try to understand the ERP system which I have shown you, this is not completely automated. Why? Because it required human interventions. Human intervention means when I was initiated anything, it was going to some of the offices where they manually checking these details, right? And they try to see, yes, some fund is available, this fund is not available, this is allowed, this is not allowed, and so many things they have doing it. But yes, if I make more efficient system, then I need to add some AI part on that, so that if fund is available, no need to hire the staff member. It will automatically go to my summary sheet. I can see that this is available, right? But the challenge is again human intervention is required, because they need to check, sir, whether this is out of rule or whether this is in rule, whether it is this item is allowed or not allowed. So many things are there. So that's why a lot of difficulties are there to make it completely automated. And same challenge was facing when we are moving towards the industry 4.0. Anyway, so what I'm trying to convey from this particular slide, that in industry 4.0 we are still using 3.0, 2.0, 1.0, whatever, but some new smart technologies need to be added. For example, I wrote a term, cyber physical system. I hope you must have understood this term. If not, I have made one slide, particular slide for this also. The another thing I mentioned here, Internet of Things. I believe that some previous speaker must have covered about the IoT and the networks. So this is the current scenario where we stand now. Now, for this, I have a small video. I think, yeah, it can run directly. It's a small 2-minute video. Let's see what I have. This is talking about 3.0, right? So you must have seen what I have tried to convey from this particular slide. It was shown in these small videos, and a lot of new terminologies AR, VR, and all those things were introduced in the last second, right? So this we need to understand in the end of at least this talk. I hope that you must have aware about these technologies, but at least try to make the better understanding after finishing this particular talk. Now, what exactly is the industry 4.0? From the previous video, what we can define is that in this particular era, we are going to use we are going to use this physical systems which was already there previously in 3.0, that there was machines, there was equipment, there was robots, right? So how we are dealing with this? I mean, how we are dealing with our students? Let's say, assume that our institution is a like a industry. So what we are giving, we are providing some basic trainings to our students on these particular machines. And in polytechnic level, you are making them trained to use it more efficiently. And at the graduation level, we are trying to convey the theory part of that, right? Some sort of research, some sort of integration of the recent technologies on that particular area, right? So that means nothing is new. What is new here, that is bolded here, that whatever physical system you might have it in your institutes, that's why I mentioned very small things. We have machines, we have some sort of equipments, irrespective of your branch. We have some sort of robots. Now, the integration should be from the recent digital technologies. These are AI, artificial intelligence, very catchy word. Everybody is talking about nowadays, but nothing is new in my perception. Again, IoT, Internet of Things. This is new, I can say, in some sense. Cloud computing already was there, but now we are using it more efficiently because that ERP system is a typical example of cloud computing. I have whatever data stored in the cloud, right? I no need I mean no need additional arrangement in my PC to use that particular modules, right? So these digital technologies and the analytics. So whenever I'm talking about the analytics, that includes your AI, machine learning, and all new words. Now the objective is to create a smart, connected, and autonomous factory. So I hope that Industry 4.0, I try to cover in a very basic definition. In future, if somebody asks you what exactly is Industry 4.0, so in my perception, nothing is new. Only thing is that we need to add these technologies to make the more efficient system. I have shown you one system in the beginning of the talk. We try to relate your system with our system for the better understanding. That mine is more smart, more connected, means I no need to go anywhere. I can do it from my office, and it is a sort of automation, right? So this is the basic definition of Industry 4.0. Lot of bookish definition you can see, but the main thing is the understanding. Now, for next step, what is the core pillars of Industry 4.0? Let's say I can ask you one question, that can you think what are the core pillars of Industry 3.0? Right? Then of course you may think, sir, some sort of mechatronics, some type of automation, some sort of machineries was there, right? Consider the example of lathe, consider the example of CNC machines, consider the example of any advanced manufacturing, consider the example of any thermal related machineries. So some sort of electrical part, mechatronics was there. Yeah, you can see the screen in your machineries, you can operate it, you can write the code and all those things. So almost this that part was here, but the 9 pillars which was found in very good books are listed here. So these pillars, 9 pillars, maybe I will take 1 or 2 minutes for each pillar to explain you that what are the core pillars, and this is the overall theme of this particular FDP. The first one is the, let's say, the blockchain, right? So we must are hearing the blockchain, and the typical example is the, you must have heard about the Bitcoin and all those things, virtual money, right? So they use decentralized control to make the virtual data their security part and all those things, this comes under the blockchain. See how we are going to make the smart things, how we are going to make the smart systems. Only one line message which I try to convey you is that lot of research is going on across the India, across the world. What is what other people are doing, especially the USA and Japan and developed countries, they are very smart in nature. They initiated this concept that can we use the existing data. Otherwise, what is happening? Whatever research you are doing at your institute level or during our PhD or masters or whatever, we are doing some particular task, and our objective was that you do something and try to publish the paper, and maximum you go for the patent, chapter is closed. Now, the smartly, what other people has started, they started using the available data, right, and make the smarter system. So the first doubt was whether my data was reliable or not. Let's say Samaji sir is working in some area and I am working in some area. Somehow he has published some paper and I have published some paper. But how can we rely that which work is more reliable, which work is more authentic when we go for the next step, right? So the overall objective is why we conduct the repeated experiments. Why cannot we use the available data? And these are the very core things which DRDO, ISRO, I mean, all the things are implementing. Recently, I'm working with one project with DRDO. There also we are talking about a lot of material things. In general, the people are thinking materials means nothing. Simply, they are developing some new materials and they are publishing papers. But I will show you how this technology is helping that you no need to develop new material. Collect the data from the existing material and go ahead for the manufacturing. Anyway, so the blockchain is some sort of Bitcoin is the typical example. Second is the Internet of Things, IoT. Again, IoT is the new terms, right? But we all are using it from long back. The basic example which I am giving to people is our vehicle. You can see that some ultrasonic sensors are there and they are guiding you that this much distance is there from the another vehicle and from the previous obstacle and anything. So it is showing in your screen some sort of, right? So that means some sensor is there which is visualizing something and it is helping you. Otherwise, what is happening? I mean, one person is needed, which will be stand there and guide you that come back or move forward, and what so many things were happening, right? So they use very smartly the IoT things in, let's say, vehicle, and this is the thing which most of the people now using in recent technologies. Even I will show you some examples in the medical applications also, aerospace, defense. IoT is very popular, and simplest one line thing is that there should be some sensors, there should be some integration part, some controller, right? And some sort of programming we need to write it to better execution. And IoT now has introduced in the school level also. At IT Jammu, I have initiated very good initiative in this area for the school teachers and for school students. We are developing the school experiments. For example, all of us gone through the school things, and if you remember, 20 years, 30 years back, whatever books we have studied, same books are followed in the school, right? But if you compare the foreign studies, the foreign schools, they are less in content if you compare from the India, but they are more towards the application point of view. So the major part is, can we integrate this IoT thing in school level so that they can develop the setups? For
Ka-
example, the ultrasonic sensor, which I gave example
Palan,
recently, can we make a small setup to find out the speed of sound? Speed of sound was given in book some 330 or something, and we are using it for calculations. But there is no experiment at all to understand how can we find out the speed of sound. Okay, so for to find out any speed, we need distance or time. So if we have an ultrasonic sensor, some sort of coding I can write,
ayo kudu nela.
and from Raspberry Pi, some Arduino I can use it
Camera
and
bandi.
make a setup that I can measure the speed of sound in the screen, and if I change the system, it will change it. If I change the medium, sorry, if I introduce some ice, rather air, it will change the speed of sound because of the medium. So these are the experiments we are integrating in the school level. Anyway, so the first part was the blockchain. We need to understand, you need to go through, I mean, some YouTube videos, some collaborations. Similarly, for the IoT things, you can learn it very easily. You can collaborate with some of the electrical engineering faculty members. They are very frequently using it. Now the third part is the
Now,
cloud computing, right? Again, cloud computing. The cloud computing was the example of the ERP system. Then cyber security. This is the major threat in this industry 4.0. Means, as I told you that we are going to use the existing data, right? Anybody can manipulate the code, right? And destroy my things. For example, recently the drone attacks and other things. This was the major challenge. How can we dismiss their drones? And even lot of our financial transactions. The major worry was the cyber security. Then the system integration. Whatever technologies I have talked so far, blockchain, IoT, cloud computing, cyber security. How can we integrate into the system? Once you integrate into this system, you can analyze it from the big data which was available from the previous things or the available things, okay, and then you can move for the smart manufacturing. So this all steps are very very important where we are talking about industry 4.0. Sometimes doubt is coming in our mind, why we are moving for industry 4.0, what is the need? And this is very true. I am also thinking the same thing, that it is not applicable and not useful for every type of application, but yes, this is applicable in very dedicated, very complicated systems, like when we are dealing with the security systems, when we are dealing with the defense equipments. This is very very important, because ultimately you are going to use some sort of communication, some sort of sensors, some sort of chips and all those things, right? Now, when you going for this smart manufacturing, people are very smartly using the artificial intelligence. I hope that this is what is very, very popular and we all are doing in each and every day. But we need to understand this is nothing. It's a already existing thing. Earlier, it was used as a term optimization. Now, here we are using it the artificial intelligence. And last, that you integrate all those things in a cyber physical system. You have some sensors, you have to cover the threat part, you have to cover the blockchain, you have to cover the data, and in the last you can propose some sort of cyber physical system. So this is the overall typical example to understand what exactly is the industry 4.0. Now, in the next whatever time I have around 25 minutes or so. I will try to cover these things in 1 or 2 minutes. Let's say the first part was the IoT, right? So IoT is what? IoT in Industry 4.0 connects device, machines, and system to exchange the data over the internet for automation, monitoring, and control. And the IoT example I have gave you from your vehicle. Every day you are using, right? So this is the a typical example, and here you can see one small video.
The internet isn't just about computers anymore. Now, all kinds of everyday objects can connect to the internet, including cars, thermostats, sporting equipment, refrigerators, and even shoes. This is known as the Internet of Things. Now, you may be wondering, why would shoes need to connect to the internet?
This is the
Well, the
typical
shoes can
example.
collect data, like how many steps you take, which can be viewed from another internet-connected device like a smartphone. All the metrics collected by the shoes can be analyzed to tell you how many calories you've burned, give you personal.
Like you have seen that some sort of IoT system is there, which is calculating each of your physical activity, some sort of suggestions and all. You must have heard that a lot of medtech technologies has been developed, right? Where they are guiding you. I'm not saying that it's a god, but they are at least guiding you that this you can do, this you cannot do. This is the status, current status of your body. This is the current status which you more needed, right? So this is
Fitness advice, and much more. But the Internet of Things isn't limited to consumer products. There are city trash cans that send alerts when they need to be emptied, sensors on bridges that check for stress or damage to its structure, and many more examples extending to healthcare, manufacturing.
right. You must have seen that the safety part of the bridges and all can be taken care by the this thing. So what I'm telling you that people are trying to use this technology, these and technologies for the better human life.
And agriculture, among others. Unfortunately, there are also new security concerns. For example, if you have internet-connected locks, a hacker might be able to unlock your front door
Exactly.
remotely. And there's the issue of privacy. All of these devices are collecting large amounts of data that can capture your actions and location throughout the day. Often, we don't exactly know all that is being collected or how this information is being used. The Internet of Things is going to grow exponentially over the next few years, bringing with it new benefits and challenges.
Right. So whatever we have discussed so far, it was covered in that particular video. That is the IoT things where you can relate that can we use IoT in your research? Can we you use IoT in your things? It's an open door, right? There is no restrictions that IoT is the, for a particular application. But the only thing is that we need to understand that what IoT can do it. I believe that some of the thermal, some of the design, some of the electrical faculties are maybe students or faculty are there. They can try to make something out of this technology, and we can learn easily that how can we use this technology. Now for the IoT thing, as I told you that it required, just a minute. Yeah, it required application layer, then data processing, network, and the sensing layer. So here I wrote you that how it works, right? So sensing means there should be a sensor. Please try to consider the example of your vehicle. Sensor detect the parameters, whatever temperature, pressure, vibration. In your case is what distance, connectivity with the data, processing, and the application. Decision sent back to the actuator machine for the control. So this is the thing how IoT works. Now, second one was the cyber physical system, which I explained in the last, right? Cyber physical system. But we need to understand here because recently I covered the IoT part. Now, how IoT can make a physical system and what exactly is this? So please try to understand from this definition, very basic definition. This is the integrations of physical components and cyber components, software, sensors, and well as the data analytics connected with the internet. So let's see how it works. And very much focus is there from the government side in this area.
Did you know that it is possible to detect traffic accidents from distant control rooms using roadside infrastructure? That doctors can monitor cardiac patients via specialized mobile apps? Or were you aware that the Delhi metro train you may have traveled in was perhaps the driverless automated train introduced in 2020? Well, the operation of these technologies is based on the emerging field of cyber physical systems, or CPS. In turn, it is part of the fourth industrial revolution, which builds on the digital revolution and applies various disruptive technologies like cloud computing technology, big data analytics, human machine interaction, robotics, and automation to advanced engineering and manufacturing. In essence, cyber physical systems are based on the convergence of the physical infrastructure and the cybersphere. It utilizes engineering models and automated systems from diverse fields like mechanical, environmental, civil, electrical, biomedical, healthcare.
So I'm not covering the full video here, but if you are interested, then you please contact the coordinators. I have all the videos. I will share you later. So here you can see that cyber physical system was the integration of your existing things with the cyber component, which we discussed from last 10-15 minutes. Now here is the overall structure of this particular system and how it works. So very simply, in one slide, if you wanted to understand, because it is separate books, because computer science and electrical faculties are expert in this particular area, but how it works, then there would be a physical world like this, machines and sensors, then cyber world, data process, where you have to take care of the security as well as the AI and analytic part, and then of course there will be a controller system which can decide, and then basically the application whatever command is given. So in this area you cannot start work directly. Only thing is that you can work on your application part, and collaborate with the electrical or computer science guys, which can help you in the cyber as well as the making the decision part. Then you can create your own system, then you can create your own research interesting in this particular area. So this is about the cyber physical part. Now the third pillar, if you remember, was the cloud computing and the big data, right? So again, this is taught by computer science guys, but if in a null set we wanted to understand, that is the best slide to understand. The cloud computing means the enables remote data storage, sharing, and processing, like in case of my EG system, ERP system. It provides scalability, real-time access to production data from anywhere. For example, I can show you my ERP system from anywhere. I no need to collect some sort of hardware, collect some type of things which can store my data and show it to you. Similarly, what is big data? Big data refers to the massive volume of the structured and unstructured data. As I told you that let's say I am working in some particular area and sir is working in some particular area, almost similar area, let's say, and we observe some different phenomena, some different experimental data on some common work. So it's very difficult that whose data is more reliable and maybe more useful, right? So lot of structured and unstructured data was available, huge data, right, generated from the sensors, machine, or scientists, or some systems, and then basically it will start the analyzing with the help of AI, with the help of some other models and all those things. So this is a basically subset or some type of overlapping between the cloud computing and the big data. Now this slide, why I mentioned that we need to understand whether they are same or some difference is there. So what is the relationship between the cloud computing and the big data? Let's say data generation. In case of data generation, there is a cloud role, but there is no role of big data role, because data is generated, right? You can generate some data with the help of IoT and sensors. So IoT enabled machine sends data to the cloud. It is sending only the data, not any analysis part was important. So that's why the output is the real-time rate data collected. For example, our individual research can be stored with the help of cloud computing in some particular cloud. Similarly, data storage, but data processing, when we talk about the data processing, both comes into the picture, because the cloud computing provides on-demand processing, that in what particular area data is required, and the big data was available, so it can help you the processing part. Similarly, the analytic part also involves both, and of course the decision making involves cloud role as well as the big data. So this is the typical example where the cloud computing and big data relationship can be found. And this I found from very interesting source, so which is listed in the bottom of this. Now, the fourth pillar was the sensors. So I think we all are knowing sensors, actuators, and all. So again, please understand the sensors are the device that collect the real-time data from the machines or from any source or from the environments, forming the foundation for the automation. आप लोग समझ रहे हैं? We are collecting the data, right? हमें क्या चाहिए? Data. That data may be collected from whatever discussions so far happened, and to make the automated IoT and Industry 4.0. So if I talk about the typical sensors, you must have gone through different books. So this I have taken from one book that we all are teaching our students in automation and in mechatronics courses, that these are the typical sensors, and we covered the theory part of the sensor, that how the sensors works, how the sensors calibrate. Okay, so that I think you also doing the same thing with your students. But the here thing is that can we make the IoT based device by using these small sensors? Right, so in very small cost you can develop some experiment for your students, or you can give some projects to the students, then don't buy from the market, try to apply the IoT thing by using this small sensors, which are very easily available in the market in very low cost. Now automation, I already trying to explain from my EG thing, ERP thing, right? So automation definition is the use of the technology, control system, information technology to operate equipment, process, and system with minimum or no human interventions. I have collected one video. So the live example was my ERP system, right? And industrial example is here.
Industrial automation is the process by which machines, robots, and computer systems are used to control and optimize production processes in factory or industrial plant. In it, sensors and control systems such as SCADA, PLC, and HMI are used to monitor and regulate production in an automated way.
Have you heard about SCADA? Right, SCADA is the supervising control and data acquisition, right? So there we are using SCADA now.
Increasing efficiency and reducing costs. It can also improve job security by reducing the need for dangerous and repetitive jobs for people. The use of automated coffee shops in everyday life is an example of automation.
See the very basic example of automation, right?
In these coffee shops, customers can order and pay for their coffee through a touchscreen, while a machine automatically prepares the coffee. This allows for a faster and more efficient shopping experience for customers. Industrial automation has become an essential part of production in many industries, from food to automotive. From an industrial point of view, an example in automobile production is the use of robots to weld and assemble parts. This allows for more accurate and faster production of vehicles, which translates into lower cost and higher quality. Would you like to learn more about
Right? So this was the example automation. You understand that this is always required at multinational companies. You need to understand the need because the trend is going to be changed very soon. Maybe in 5 to 10 years, you will see these are very small things, small shops, small good things may be available in the market. It's a huge scope. We need to guide our students. Even for our understanding, also we need to upgrade ourselves to use these technologies, use these things in our research or in our teaching modules. Now, the fifth part was automation. Here is I covered the structure part. So in general, the levels are these 5 levels. So level 0 was the field level, which involves the sensor and the actuators directly, which we are using from long back. Level 1, sorry, use the PLCs, which we are already doing, and controllers to execute automatic control. Level 2 was the supervisory level, right, where SCADA and HMI are there, human machine interface systems. And level 3, the operations management level. And level 4 is the utilize ERP and business management system for strategy planning, logistics, and decision making. Right. So this is that ERP which they are showing for the hardware type of thing, and I shown my ERP where we almost in the level 4 we have developed it. Now the types of automation I am not going to cover here because it's already you are covering in the theory part: fixed, programmable, and the flexible. Right. Sometimes we are giving some problems to our students. Then can you find out which automation is suitable for your case? Case means whatever demand is there depending upon the products and all. And the sixth part in the automation was the robotics. So no need to tell anything. We all are dealing with the robotics part. The important part is the second point. Robots are physical agents for automation in the industry 4.0. Because this will be the part where we can think about the manless things only. Without this, it can't happen. And the modern robots are integrated with the AI, sensors, and whatever 9 pillars I told you: computer vision, IoT connectivity, allowing the collaboration with cobots, means humans, and the adaptive decision making. And the robotic combined with big data and the clouds enables real-time learning and the optimization. These are types of robots in general. We all are aware about it. Now, AI, right? The seventh pillar was the AI. Again, no need to define because you can define AI in your words. Every day we are doing in daily life. For example, if you are meeting with somebody, you can easily recognize that I know this particular person, right? And if you make some system, some camera type of system in out of your office, so that my camera will detect from this previous face and tell me that this particular person is coming, and it can show in my screen that this particular person wanted to meet me or coming to my office, then I can see on my screen, right? It's a basic example I am giving to understand the AI thing. But at the same time, AI is now in everywhere. That we need to understand what is the key roles of this AI in the industry 4.0. Right? I gave you a very rough example to recognize the person by using image processing, machine vision, and all. But we are using it for the predictive maintenance. Detect the machine failures before they occur. Also for the quality control. identifying product defects using computer vision, supply chain optimization, of course, for the demand, forecast demand, and optimize logistics, as well as the autonomous systems like robots and AGVs, automated guided vehicles, making independent decisions. Even this the last part, na, AGVs. So these people are not talking about autonomous guided vehicles. Already, when I was in USA, that's one group was working, and they are probably considered AGVs in Industry 5.0 because it has a huge overlapping between 4.0 and whatever they will define for 5.0. So for AI, this slide must be interesting for you. That AI, ML, deep learning, generative AI, what exactly is this? All have some relations. So let's say chat GPT, what we are using, that is a subset of the generative AI, right? Whatever data is available, then machine learning, then deep learning, and it comes under the generative AI. So means artificial intelligence is what? Sorry. Yeah, it's the field of study, and the machine learning is what? Basically, sort of optimization, and the deep learning is artificial neural network, and the generative AI is the type of AI that generate the data that is similar to the data it was trained on, right? So that is AI. Then, of course, human machine collaboration. That means the industry 4.0 does not replace humans, as I told you. It augments them with the intelligence tool and collaborative robots that ensure safety, precision, and flexibility. And the ninth pillar was 3D printing and additive manufacturing. Because if we talk about 3D printing or additive manufacturing 10 or 15 years back, that was only restricted to SLA or some sort of um, wire based printing or some sort of polymer based printing. Now I think I do not need to run this video because we all are aware what exactly is that additive thing. Only thing is that it has been explored very rigorously in all these particular areas, for ceramics to metals, and for all these materials people are exploring it depending upon their area of interest, depending upon their expertise, right? So these all are the developed process which different researchers, especially manufacturing people or materials people are studying the 3D printing in this particular processes. And this is going to be integrate with the industry 4.0, right? Because if you give the example of a recent case in space, right, whatever failure was there, you can digitally tune it at from the ground, and with the help of AI, with the help of this whole system, it will instruct it, and with the help of this depending technologies, it can print it and going to replace that particular component in this space, and that is going on, right? You already heard this news just 3 4 years back only, right? We need to understand that what technologies people have already achieved and where we are now. Okay, so one more term, AR and VR. This is also very interesting. That's why I kept here. So AR is the augmented reality, meaning the overlying digital information on the physical environment through device like tablets, smart glasses, and heads, as well as whereas the virtual reality creating an immersive computer simulating environment where users can interact with the virtual objects. Right? I have one video. I believe that most of you are aware about these things because a lot of things are happening in AR VR. But let's understanding this from this video.
These days, we spend a lot of time looking at screens. Computers, smartphones, and televisions are a big part of our lives. They're how we get most of our news, use social media, watch movies, and more. Virtual reality and augmented reality are two technologies changing the way we use screens, creating new and exciting interactive experiences. Virtual reality, also known as VR, uses a headset with a built-in screen that displays a virtual environment for you to explore. These headsets use a technology called head tracking, which allows you to look around the environment by simply moving your head. Augmented reality, or AR, is a bit different. Instead of transporting you to a virtual world, it takes digital images and layers them on the real world around you. This is done through the use of either a clear visor or a smartphone.
Right. So I'm telling you that the things are going to be changed in academics also. Very soon we are going to use AR, VR for the experiments and all. Even a lot of biological experiments at school level or graduation level. This type of experiments have been developed. where students are getting benefits by using these technologies. Now, one more term which I thought that I should discuss in this particular FDP is the digital twin, right? It's a very new term which people are now going to use it, and already all big MNCs and public sectors are investing a lot of money in developing the digital twin. So digital twin in one line definition, again, it's a new word, is a virtual representation of a physical asset, process or system continuously updated with real-time data to simulate, predict and optimize the performance. Better to understand from this video.
Digital twins, the innovation backbone of the future, delivering virtual representations of real-world products, systems, and cities. For example, the digital twin of an electric motor not only showcases form, but also analyzes functions, from the rotation of the shaft to thermal conductivity to data from sensors and beyond. What's more, the digital twin continuously evolves thanks to the flow of data, user experience feedback, and new input, and it's greatly impacting development, production, and operation. In development, a product's behavior can be simulated and tested long before a physical prototype has been built. Siemens utilized the digital twin to develop a world record-setting electric aircraft motor that not only weighs 50 kilograms, but is also.
So you can see that whatever simulations, whatever data is available, right, from various research, various sources, now they are trying to make the digital twin so that it can help in finding the failures, in finding the simulations, in finding the optimizations and all those things, right? So the digital twin was very much helpful in the space sector, as I told you recently, that whatever problem is happening there, you can visualize is here, and now virtually the machine, whatever additive manufacturing machines was there, no need human intervention, it can go and replace that particular component, right? So that type of research, now people are very close to achieve the success in these particular areas. That's why it is very important to understand. At least I'm not saying that you start working immediately in this area or anybody can start working in this particular area, no, but it required a very good collaboration from different, um, departments. So like this digital twin is working. Already I covered in the video. So Sambhaji sir, can I take 5 more minutes? Yeah.
Eh, Yes, sir.
Can I take 5 more minutes from
Yes, sir.
now?
Yes, sir. Yes, sir.
Yeah, because I'm very much close to my end slides. So this is the digital twin, which you need to understand that how it works, and it's not only for the hardware system, even for lot of gas agencies, lot of oil sectors, people are developing the digital twins of their system. Maybe you can find it after the talk. So cybersecurity, I already covered in the beginning that whatever we are doing, the major threat was the cyber part. So that we need to taken care of. And the last one was the blockchain. So I told you that blockchain was the it is a decentralized distributed digital ledger that records transactions securely and transparently across multiple computers, right? So I told you the example of Bitcoin. Even you can consider the example of recent lot of things that you can store your vehicle details in some portal, right? So this all comes under the blockchain technologies. Maybe 1 minute video you can see it. Right, so this is a blockchain, and now if you integrate whatever discussion happened, right, in a small factory, then you can say that your factory is a sort of smart in nature in many of the applications, right? So if I summarize and give some threads, so the major issue where the next future, where the next time people are thinking before starting this work or applying this work is the operational technology meets the information technology. where cybersecurity can help you to meet this requirement. And this is the typical Siemens example, Siemens factory, which is developed at Germany, right? So these are the some cases which I have taken from the different sources, and this is the real case study. I can show you through the video rather going through the slides. Yeah,
In the factory of the future, both the workpiece and the machine will be intelligent. They will be completely networked and control production autonomously, and in a way that is more efficient and uses fewer resources than ever before. The possibilities are so vast and groundbreaking that many experts refer to it as a fourth industrial revolution, Industry 4.0. The first steps towards Industry 4.0 have already become reality. It all starts when mass production components become a unique item with their purpose predefined at the outset. Because even before manufacturing, the component exists in virtual reality, including all the information required for its production.
right. So from the very basic video, they explain that what type of systems can be developed, and one report, very useful report, you can see it here, that by applying this thing, this is the case study, 99.99885% quality rate. That means the only 12 defects per million products was found, as well as they improved the productivity by 140%, and energy consumption they saved, and all those things, right? So this is the one case study which I thought that I should discuss, at least for the better understanding, because from the Indian perspective we always thought that why it is important, how can we do it, right? We need to understand that it is not required each and everywhere, but it is required when we are dealing with the high end products, high end technology, machineries, and all those things. So if I talk about the in general applications, then of course we have discussed the application in the manufacturing. Of course, there is application in agriculture, precision farming, and all. And healthcare, I shown you one video, smart wearable devices for patient monitoring, AI-based diagnostics, right? Even in the last, energy sector, right? So if you go to now in developed countries, even if you go for Dubai and all, you can see the smart grids and the predictive energy optimization. Lot of setups are there which are automated in nature, and they are saving lot of power consumptions. So of course, from this talk or from the general scenario which you are hearing here and there, that some benefits are coming in mind, but at the same time some challenges are also coming in our mind. A major challenge I mentioned here, it's required high implementation and integration cost. Of course, the cyber security is the major threat, and we don't have skilled workforce on that, but we need to create the workforce by introducing this courses on the laboratory type of things at the graduation level, so that as a teacher our responsibility is to touch those areas, and they can elaborate further depending upon when they go for the job. So overview, it is a rapidly adopting smart manufacturing and digital technologies to complete globally, and government initiatives, industrial policies, and private investments are driving adoptions. And the key drivers are a lot of government programs under Make in India, Digital India, and smart manufacturing, and increasing industrial IoT adoption in automobile, steel, in almost other sectors as well. And there is a huge scope for the collaboration between the startups, institutes, and technology partners. And this is the skill required for this. As I told you, this is not a single man task, right, which is now happening in India, that somebody is working in some thermal concepts or thermal thing or CFD thing, he's only doing that things. So how we can collaborate with the, let's say, thermal guy, how we can collaborate with the robotics guy, can we use their knowledge by getting some data, and some interface can be developed with the help of from electrical electronics guys, and makes something fruitful out of that. So this is the emerging trends which I thought that I should wrote here for the summarizing this. Thank you. Yeah. So I hope that you must have get some clarity on this, because most of the participants are listening similar type of terminologies maybe from last 3 days, right? It was started on Monday.
Yes, sir. It
Somebody
was
said this
started.
work this workshop was started on Monday, right?
Yes, sir. Yes, sir. It was started
Today
on
is,
Monday.
yeah, today is fourth day.
Yes, sir.
Yeah. So anybody?
Dear participants, if you have any query or doubt, you may ask to Mr. Pal sir.
Actually, I thought that, I mean, how can we explain this thing in a very small time? Because we have developed some setups also
Yes,
for
sir. Yes,
giving,
sir. Yes,
providing the
sir.
training so that because it's not a single man show, right? Nobody can touch these areas in a one day.
Yes,
We need
sir.
to
Yes, sir.
understand. So what we decided when I joined in 2018 here, that rather making a physical setups, better to make the process smoother. What I learned from Kanpur, that sometimes it takes a lot of time for the approval and all those things. So we discussed internally because we are the new faculty there and very active team. So we thought we can start something which can be very much useful for at least institution levels, right? And now other institutes, even state governments are also approaching us to develop similar type of setup for them, which is more efficient in nature, even more transparent in nature. I can see what type of comments my next uh, level head or dean has been written in my file, right? So I can see it immediately, what was the justification and all. So similar things now people are trying to implement this industry level. But the major problem is India is the research part. If somebody is working in thermal CFD, so he is thinking that I can only do CFD. The collaboration part is very much lagging, which is now this government is very clear that they wanted to push the strong collaborations to make something out of with the available data. This is the
Yes.
overall summary I try to convey from my talk.
No. Yes, sir. Hmm. Sir, I think there is no participants who have any query or doubt. So, with your permission, shall I conclude this session?
Yeah, yeah, please.
Sir, thank you very much, Dr. Vijay Kumar Pal, for delivering such an insightful and informative session on Industry 4.0 towards sensors, IoT, and automation. Your detailed explanation and practical insights have truly enhanced our understanding of how sensors and automations are transforming modern industries. On behalf of Mahavir Polytechnic and all the participants, I extend our heartfelt gratitude to you for sharing your valuable time and expertise with us. I will also like to thank all the participants for their active engagement throughout this session. Once again, thank you so much, sir, for your valuable contribution to Atal FDP on Industry 4.0.
Okay, thank you, sir. Thank you for inviting me, and thank you for your institute for doing this wonderful arrangement of this FDP. And best wishes for all the participants. Thank you.
Dear participants, please uh, fill the feedback form and complete the assignment. We will share the feedback form in chat box also and as well on WhatsApp group also.